Well, this problem is for Ahmad. I'm getting ready for my fall tutoring, and I've got to get the kinks out from over the summer. Ahmad, you indicated that you got a soda can or some kind of a can containing a fluid, and that the volume is going to be 12 fluid ounces. You want to minimize the amount of metal that's used in production of the can. Well, you Google, the fluid ounces isn't going to do any good for the dimensions, so you could easily convert it to 1 fluid ounce is equal to 29.6 cubic centimeters. So 12 fluid ounces is going to be approximately 355 cubic centimeters. So we know that that's our volume. Now, over here we have a right circular cylinder, and you may remember that whenever you have that type of a solid, you can take the area of one of the ends and multiply by the height to get the volume. So now I can say that the volume, which is 355, and our answer is going to come out in centimeters when we're all done. So 355 is equal to, now the value of the volume here is going to be the area of either end times the height. So the area of the end, pi r squared, and the height is h. So that is going to be one of our equations. Our goal here is to get down to one variable. Right now we've got an r and an h. We're going to have to get rid of one of those. Now the other thing that we have is we have the total area, which is what we're interested in. And the total area is equal to the area of either end plus the lateral area or the sides. So let's figure out what the formula for that is. Well, the two ends, each one is a circle with radius r, so our total area is going to be equal to 2 pi r squared, the area of each circular end. Now what about the lateral area? Well, if this were a soup can or something and it had a paper label on it, what I could do is I could just take and cut that label going down the height, and what I'd end up with is a rectangle. That rectangle would have a height of h, and it would have a length of what was the circumference of the can in the first place, and that's going to be 2 pi r. So the area of the sides here is going to be plus 2 pi r, that's the length of this rectangle, times h. Well, now comes the typical problem for the calculus student. You want to take the derivative of this so that you can minimize the lateral area, but you've got two variables over here. So we want to get rid of one of them. Well, the way we can do that is go back to this original volume formula, and we can say that h is equal to 355 divided by pi r squared. So now, the only a we're worried about is the total area, so I won't subscript it, is equal to 2 pi r squared plus 2 pi r times, now h is going to be 355, whoops, divided by pi r squared. From here, there's just a little bit of algebra, and taking the derivative of this, you should know how to maximize or minimize that. If you have difficulty with that, what you can do is you can email me at rich.valen@facebook.com. I am a academic tutor for high school and college students. I do calculus, pre-calculus, etc., and physics and chemistry. I'm an ex-high school teacher. So if you run into a problem, rich.valen@facebook.com. if you run into trouble from